So hello again. I'm doing the second video today to just show you the hierarchy in VHDL. So integrating submodule, the notion of component within a top-level design, and also using that to discuss a little bit the notion of block divider. So let's go. Again, I'll share my entire screen, and for that, we'll implement a module that just do the following, that will switch the LED, so get the clock, and then just map the output to a 7-segment display, another 7-segment display to 7 LEDs, and then let it blink. So for that, we'll create a new project like we did before, starting a new project with new Quartus project. And then since I was within a project here, if it asked me if I'd like to close the current project, I'll just say yes, the current project will be closed. Then I'll provide here the location of the current project. I'll not call it a tutorial 2025. I'll provide a different name here. And then we'll call this one here Blink. Let's say Blink 2025, right? That's just a name. And then we'll call this project here Blink 2025. So the project does not exist, the folder does not exist. We click yes to create it. We have the project as an empty project. We're going to be creating the files, and then I'll click here next. And we're selecting the corresponding board, which is the Max 10. And here we're going to be picking the Max, which is the Max 10 FPGA. And here we're going to be picking it's the D10 light, right? Max 10 on the D10 light. And then next, setting here to be VHDL, and then the Quartus sim, even though we're not doing simulation just now. And then finish. The project will be created. And the first thing is when the project is created, we'll go ahead and create a new VHDL file. And this new VHDL file, so we create the new VHDL file. And this new VHDL file is going to contain our code that will be mapping the LED to. So I have the code already implemented here. So I'll just copy it from this file and then type it in. And then I'll call the code here. The code is Blinky. We can call it here Blinky Fast to state that the Blinky that we're doing here is a fast. So it's the fast version. I'll call it here Blinky Fast. Blinky Fast. And then I'll change everywhere that needs to be changed. Otherwise, I'm going to be getting error during the compilation fast. And okay, so we have entity Blinky Fast. We have in as input the clock. So here we don't do much. We just take the clock as input, and then we output the LED, 8 LED here. We have a total of 10. We're going to use only 8 of those. And here I have the architecture behavioral of Blinky Fast. And here what I do, so we check, it takes as input the clock, input clock, and then it checks if we have a positive edge of the clock, then it will flip the value that we had at the output. Because we can read the output directly, we're using a temporary value here that we call a signal, we call that a temp, which means that this value will have to be declared here. So we'll call it here signal temp. And because the temp is, we assigning that to the 7-digit here is going to be of type standard logic 7. So we're going to take the temp here, internal signal. So double point here and then type standard logic 7, and then we'll put the semicolon. That way we're declaring an internal signal temp that's going to be used internally here because we can read internal signal. We'll just be flipping this signal at the frequency of the clock, and then that signal will be assigned at the end to the LED. So this is our design. Now let's compile and see if it works. Compilation. Now it will ask us if we save in the file or not. I'll first, let's say, save in the file. Click here on save. And then we should not use the Blink 2025 as the entity name, as the file name. The file name should be the same as the entity name. So we'll call it here Blinky. And then we'll put here fast. So Blinky fast, is that name correct? Yes. So Blinky fast. And then we can go ahead and compile these and see what happened. If we have some errors, it's going to appear here, and then we'll correct it. Now we're having two errors. Let's see where those errors are. The first one is here. Okay, we're having this comment that is misplaced. And signal, some follow-up error. This one is another error. And then, yeah, let's try again. Okay, temp is used but not declared. So I've declared here the temp but not TMP. So we're gonna modify that here now as TMP in order for it to work. So let's try again. Okay, so now we're compiling without any error. And then we'll follow the same principle like what we did last time. After compiling, we're going to do pin assignment. We use the assignment editor. And then our assignment editor, we need to provide the value for the LED. Before that, let's put our design as the top level. So we go under hierarchy, select the file here, and then we put the Blinky fast here should be the top level. We set it as top level. And out of so abundance of caution, I'll compile again to make it to bring this design at the top, and then I can do the pin assignment after that. While it's compiling, I'll now pull our Quartus file here to make sure that we have the correct pin assignment. So it's not all provided here. So I'll look into the DE10 the D10 light manual, and then we'll check where the LEDs are. So where the LEDs, SRAM, probably at the beginning. Okay, yeah, the first thing is that I'll identify the clock. Now let's go to the pin assignment. We'll go on assignment, then assignment editor. And like we did last time, we'll scroll completely down, and here we'll find the magnifying glass. Oh my God, no, Quartus has, yeah, Quartus has crashed. Let's see if we're starting the Quartus, and let's see if we can get our project back. The project is there. And now let's see the assignment editor, and then we'll scroll down again, and hopefully Quartus doesn't crash this time. So we click the magnifying glass, and then on the list here, we search to see everything that will appear. So here we can see the clock, and then we can see all the LED signal. I'll click the clock here, then I'll click each of those signal one by one. Sometime assigning in group may cause some issue with Quartus. It's a software that is really weird. And then having selected all those, We'll assign all of them location. So location. Then the next one also location. The next one location. 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 So I'll assign all the signals here, but the next design that we'll do, I'll just use maybe 2 of those and then let you do the remaining assignment at home for the remaining components. So we'll just use like maybe 3 or 4 location. And the 7-1 also location there. Okay. And then the last one, location. Okay, for the clock, we know seeing here the pin 15, this is what we'll assign the clock, which is 10 megahertz here to our design. That's the pin N5. Come on, pin N5 is the value we assign to our design. Clock here gets the value of pin N5. And now let's see what the LEDs are, and we're gonna be assigning which value are we going to be assigning to the LED. So we have the switches, and then here are the LED. So pin A8 here up to B11. So I'll start with the A8, A9, and A10. I'll assign that to the first 3 in A8. A9 and A10 are the first one I'm going to be assigning in A8. Then I'll copy it in A9 and PA10. Pin A9 and here pin A10. Then the next one are gonna be the B10, D13, C13. B10, D13, C13. So here, B10, B13, and B13, B10, D13, and C13. Yes, B13, and then the next one is C13. And then the last one will be the E4 and D4. E4, no, E14, E14, and D14. And D14, so done with the pin assignment, so we can go ahead and save the pin assignment here and close this window. Now going back to our design, we will compile it, compile the design again, and then download that on the board right here. So I still have the last design in there. Can we even, you can see that correctly. Yeah, the last design is still in there, and you can see the pin here switching. Now, you can see the pin switching. Now that we're done compiling, Now that we're done compiling, I will go ahead and then download the design onto the board. So click in here to get a design download on the board, and the design is being downloaded. And now we look at what will happen after clicking here to download our design on the board. Now what happened here is that the board is currently, so the LED are currently showing no change. So we don't see it blinking. It's going very fast. It's because the clock, the top level clock, is pretty fast. That clock being very fast, our eyes cannot see the change. In order for us to see this change, we'll have to reduce the clock frequency. And then to reduce this clock frequency, we'll do that by implementing another file, a clock divider, and then adding that as component to our design. Okay, so let's see how we'll do that. Now, what I can do is that I can create a new project like we did before, and then I'll call that new project now blinking slow. So starting a new project on Quartus, yes, here, and then saving this file in a different location. Let's call it here blinky or blink slow 2025, and I'll providing the same name, so blink slow, and now we'll create yes, and then it's an empty project. Next, and then here we select our board, we select the D10 light and Verilog, and then we're done. Finish. So what we will do here now is that we will create a new file, VHDL file that's going to be our top level file. And within this file, we'll instantiate a component clock divider. So instantiating this component clock divider, we need to have it implemented somewhere first. Now, the clock divider component, we saw it in class, will take us input a given clock, input clock, and it will generate an output clock. And this output clock is what we're gonna use in order to drive our component. Now, I will get the implementation of this clock divider, and then I'll use that right here. There are many possibilities of doing the clock divider. If I know the value, like we've seen in the class, and then I'm going to be providing you the formula to compute the exact frequency of the target clock that we like to divide. So the counter here, we have a counter here, and the counter has a value in. This counter has a value in. And what we do is that we count that value up, but we also have a limit value that when the counter passes that value, it is resetted to 0. So we do it here. When the counter passes the value of, I believe, 900,000 here, this is the value that when we divided our main clock with, our eye would be able to see something going. So if we divide that by 900,000, then we should be able to have a clock that is visible to the human. When we hit the 900,000, we set the value here to 0. Otherwise, we just keep incrementing until we get to that value. So when we're done, we can assign the value now here of this temporary value here will now be generating our clock. And this clock is generated once every 900,000 times when we hit that upper counter. This will be the lower part here. Alternatively, instead of doing that, I told you in the class that I could just take an upper digit of the counter, like the bit number 24, the bit number 30, the bit number 10, for instance, and that will give me the division of my clock by 2 to the 10. This is the second option that I'm having here. In our case here, I took the clock at location, the counter at location 19 as the input to my clock. So I can use only one of those here. So for now, I'll go ahead and choose the second one, and I'll comment the first one. So this is going to be my clock divider. What do I do with this clock divider? I need to instantiate that in the code we previously seen. So I'll save this here under the entity clock divider or under the file clock divider, and then use it to build a new file. So let's go ahead, we'll save it, and VHDL Quartus is giving me the option to call it blink slow. We won't do that. We call it clock div here as the name of the entity. Now this here is going to be used into a top level file that we're going to create now. I will call that file blink slow. So now we create a new VHDL file, and this new VHDL file is going to be the same like the one we previously used. That was the blinky fast. So the blinky fast didn't have any component inside. I'll copy the code of this, but because the blinking fast didn't have any component inside and we need to use a clock divider now, we need to first declare the component clock divide. So to declare that component, I'll come here and copy this entity. And in this declaration section of my architecture, I'll copy that entity and then I'll call the entity here component. And then here I'll put here end component. So now we have a component that has been declared in a different file, and this component declared in a different file takes as input a clock that is very fast and generate as output a clock that is much slower, right? And our design will now have to attach the clock that is very fast to the input clock and the one that is very slow to the slow clock. I need to declare a signal, internal signal that I will call the internal clock signal. So I'll call it here signal. Let's call it clock here, CLK int. And this is going to be just of type standard logic. This type standard logic. And then we're going to be connecting this clock here to the output of the component here and on one end, and then use it as the input to drive our counter. So here we're going to be using the clock int instead of the fast clock. So clock int and then clock int for the slow clock, the one coming out of our module there. And here we're going to use also the clock int. And I think that's it. What do we need to do now? We need to instantiate a clock divider. So for that, I'll put here a label. I'll just call it like clock div. And then this clock divider will have the port map. We'll take the input from the clock. The input clock is going to be the clock coming from the top level, and then the output clock is going to be the clock int, CLK int. And then with that, we now have this component here that is taking the input clock from our top level design, and that is connecting the other end to the internal clock, slow clock, and this other end of this here is connected to our process. This is what we use in order to drive our internal design. With this, we should have everything we need, and then we can go ahead and save this because it's the top level of our entity. Let's call it here Blinky Fast. Entity Blinky Fast. No, it was slow, right? The previous one was the Blinky Fast, so this here is the slow. And then I'll call this here also Blinking Slow. And now we need to provide so the entity Blinky Slow to avoid error. I think that's all what we need to do. And now I can save my design under the file with the same name as the Blinky. So we'll go ahead and save this now under Blink Slow. It's showing here Blink Slow, but we're gonna call it here is Blinky Slow, not Blink Slow. Okay, done everything, we now need to compile and see what comes out. Having an error. So clock diff, port map, or is of type clock is clock diff here. Component clock diff, type clock diff here, and then port map. That should be yes. Put it here. Normally, okay, so object temp is used but not declared. Okay, so we'll also use the temp here. So we need to declare that signal. We did last time, but not here. So we're gonna have another signal here that we call signal TMP, which is for the 7 segment. So TMP, which is not part of not the 7 segment, but the yeah, I'm sorry, I put a Morse cursor here pretty large, and because I wanted you to see where I am with my explanation, but it seems to be a little bit cumbersome. So now let's compile again and see what we have. Okay, so something here begin, because we forgot here the semicolon. Oh my God, I'm having really beginner's error. So good. Now we're having a compilation going on, and at the end, we should be able to download our design and see uh, the result of that on the board. Okay, so let's see. Again, not sure. So I'll bring back the meeting here. So this is my board. I'd like you to see if it's blinking here and if we're able to see anything blinking. So I'll go on the programmer. So I'll click the programmer. It's the programmer right there. So programmer again, and then start the programming. It goes dark. And now let's look at what's happening with the board, with the switches. So it's going to take a bit of time because the clock that we have in there is too long. So even though we're able to do the clock divider, the clock has become too slow for us to see anything going on. So we'll do some modification again, and then that modification will consist, wait a minute. So one thing that we did here, we didn't do the pin assignment. So I'm sorry. We need to do the pin assignment, and the pin assignment will first consist of going back here, showing our file. And on this file here, we'll take our top level design, make it here the top level, do the compilation again, and then we'll do the pin assignment. That pin assignment is important for us to see the design being mapped to the. So this time we're not going to be assigning all the pin here. It takes a bit of time. So we're just going to assign maybe 2 or 3 of them so that you guys can see what's going on, and then you can do the remaining assignment on your own. The clock pin was the um, pin N5. This is what we're going to be using. So let's do the pin assignment here, assignment editor, and then scroll down. Yeah, Quartus. Let's launch Quartus again. Okay, blink slow, bring back our project. Okay, again, assignment editor. Then we scroll down. And here we list all the pin. And I'm gonna be assigning, we're gonna be assigning, let's try to do all these at once. And then, so here location. So I'm gonna be assigning maybe the first, let's say the first 4, just to show location. Next location. Location. Oh, no. And then location. Okay, so we have everything. Now we know that this pin here is the pin N5. Pin N5. And then we can go ahead, that's pin N5 for the clock of 10 megahertz. And then we can go ahead and assign for the LED pin A8, A9, A10. So pin A8, A9, A10 for the first location. Pin A8. And then A9 and A10. A9, A10. The next one are the B10, D13, C13, B10, D13, C13. So B10, C13, and D13. And the last one are the pin E14 and D14, E14 and D14. D14 and D14. Okay, so we now have the whole pin assignment. I'll go ahead, save the file here, close the window, and then recompile everything. We have now, as you can see here, that our blink is low, is the top level, and then include in that top level file is the clock divider that we just created. So we instantiate the clock divider as a subcomponent of that top level module. In general, when you have this type of project to implement it, where you're using a component in another component, either you put all the entity declaration in the same file, or you put the entity declaration on multiple files, and then you add all those files to your project. So now we'll try to compile again, and then to load again into our board, and then to see the result. So go here. Where's my board? Okay, that's my board. And then we'll do the start. Okay, here I have a frequency that is a little bit, that is relatively fast. And I can see how it's currently, so the clock has divided. The clock is slow, but slow fast. That allows me now to see the LED blinking here, just because one other thing that we can do now, we can play with various numbers here. If I put a number that is too large here, like if I put the number like this here, for instance, the number is going to be too large. It's going to divide the clock too much. And then the delay of the new clock is going to become too long, which would prevent me from seeing any change on the board. I can compile this here, and then we can see what I'm speaking about. So now I can go ahead, compile, and then download on the board, and you will see it will take a lot of time to move from one switch to the next one. I don't need to do the pin assignment here again because we did that already. This is the same design. I just went in there and modified a little bit. So now let's see what Quartus is doing with the compilation. It's taking a bit of time to compile the design. Okay, so downloading on the board now. Again, start. And then what we see is that the LED are off, but the two here. The off, that is just one cycle. It will take a lot of time to get to the next cycle when the clock is activated for the LED now to turn on, and then the LED will stay on for a very large period of time and so on before turning off again. So that clock, I don't think we're gonna see anything change here. The other strategy that I told you was instead of using this, you could do the following. You could just assign your output clock here to 1 bit of your counter. So if I take the bit 19 here, for instance, that will allow me to see something. So I'll change the clock output here to get the bit 19. Since I'm not modifying anything in my design, I'll just compile it and then download it again. So let's see what happened. Okay, almost done. Okay, let's here download again on the board and see what's happened. Okay, that's my design. I'll start and then download again. And now you see that with the bit in position 19, we have a clock that is slow enough, but that still allows us to see the blinking. Whereas the previous clock was pretty slow. It was slow, but it was not allowing us to see the blinking, right? So here I can see the blinking. And then what happened? So we can try various numbers. If I put it here, for instance, on the 24, then it will make the clock too slow, or maybe let's say on the 22, or maybe even the 20. Let's see if we can get something or 21 slower on the 20 here, or 21. 21 will multiply the delay of this clock here by 4, which will mean the clock here is going to become 4 times slower, which could lead to us waiting a little bit long here to see the LED switching from one to the next one. Good. So we're done, and then we'll compile. We compile now, we download on the board. Now it's download. Okay, you see it's still blinking, but the frequency here is much more slower, right? We're blinking, it's no more that fast, it's slow. Um, and then we can try this, continue trying this exercise at home. So change the 21 here, move to 24, and maybe there you won't be able to see. 24 is becoming a pretty large value, and then we may not be able to see that blinking anymore. So let's try that, and then after that, we're gonna be done with the second part. Okay, so downloading. Now it's downloading. So it's downloading. Now it went on. You see how long it's waiting, right? And now 24 is still pretty good because it takes long to switch from one number to one to the next one and so on. And if we keep going 30 and so on, we will just keep making the clock slower and slower and slower. And at some point, it's going to be no more viable for us. Okay, that's all what I had for this second video. What we've seen the implementation of a fast blinking design. Um, then we saw the hierarchy, implementing the hierarchy here with the top level module, and then instantiating within this top level module a component clock divider. We discussed what the clock divider is, and we saw different way of doing that using maybe just one bit of the counter, or maybe using a number and then switching a value to one, or toggling a value whenever the counter reaches that maximum value and then switching it back to zero. With that, I think we have all the tools that we need now to be able to implement very complex design consisting of one top-level component, multiple sub-level component, and those sub-level components can also be entity that also include other sub-level component. And this is the way we tackle hierarchy. Okay, thank you very much. And if you have any questions, so feel free to reach out and let me know. So thank you. Bye.